So it is self-consistent. The other thing I look for is it differentiable? Now, if you haven't had calculus, that probably means nothing. Or if you haven't gotten far enough in Calc 1, it probably doesn't mean anything. For the sake of not calculus, differentiable means, are there any kinks in it? And something that's differentiable is if I'm trying to find the slope at this point, if I would get the same value coming at it from the left as I would from the right. So is the tangent here and the tangent there the same? An example of something that is not differentiable is not differentiable there. So no sharp points. And, oh, it also needs to be a function. Occasionally people do this where they're doing the sketch and they have some line that's backing straight down like that. That is not a function. So thinking about it in terms of slope, an example here is we have a slope, we have a velocity of 0, but the slope is not 0. So acceleration is not 0 while the velocity is 0. That's a side question. Did any of that help? Were you just nodding to end it?
No.
Okay. Sorry, I was thinking game recognized game there. Any questions before we do a test level problem?
Would we, for the test, would we ever have like a question where we would have to consider like after the ball, not just like when it bounces back up? Is there ever going to be like a
I
question?
have done this before. In which case, I have to identify the point at which the normal force from the ball matches the weight of the ball. That would be a time. The time when the ball is completely compressed, and the time when the ball is back and they're equal again just before it leaves. So again, it's just very subtle things there. I think on the master set question, I have one where it's hitting a wall, and I have it where it just touches the wall, or just before it touches the wall, when it's completely compressed, and then just after it touches the wall. It's something exciting to look forward to. Yes, can hardly wait. All right, test level problem. Now, on a test, I give a long list of at A, the time is such and such, B, the time is such and such. I have shortened it some. I tried to draw the letters on it sort of corresponding to what's happening. So at B, that's when the box is completely on the flat part. At D, that's when the box is completely, ooh, wait, is that gonna mess me up? Oh, no, I have to move D. So D, E, F, G, H, I, J. All right. So at D and J, the box is on the flat part completely. So just after that, it has now started, the first part has now dipped over. I and E, it is on the flat part. H and F, it's on the flat part. So G's a turnaround point, and it's going to come back, and it's going to get back to M. This symbol right here is saying that there is friction on this part of the problem. No friction elsewhere, but there is friction there. So we're going to do the same exercise. We'll do it as a group this time. So I have all the way through M. In terms of presenting the solution, Which one of these do you prefer?
The left.
The left.
This one?
Yeah.
Yeah.
Huh. Okay.
Really? What were you expecting?
I was expecting one of the other ones.
There's so much more to write.
Like I said,
Yeah, I mean, in terms of taking notes, yes. The main problem with what we're gonna do, fine, I don't mind the one on the left. The main issue I've seen students run into is more apt to double up. That they'll have something with position of 0 and position of negative at the same time, because they got the parenthesis or the bracket wrong.
no, I'm not trying that.
Oh, I need to establish an origin, so let's put the origin here, origin. I also want to point out that it's not like the box is going underneath it and then it goes around on top of it. It's just, I need to somehow differentiate. The box is traveling in the order of time, and it's on top of this structure the entire time. So position, displacement, velocity, and time. Positive, 0, and negative. Not time, sorry, acceleration. So let's start out with position.
This one.
I find it helpful to establish where 0 is first. If we look back over here, if an object goes from plus to minus or negative to plus, it has to go through 0. So this is the point when it goes from positive to negative velocity. This is the point when it goes, displacement. This is the point when it goes from positive to negative velocity. You can't go from plus to negative or negative to plus. It'd be helpful probably if I use this parallel structure there, from positive to negative or negative to positive, unless you go through 0. Because again, we're not ripping the space-time continuum. All right, where is the position equal to 0?
Which one's the positive side?
Oh, thank you. Let's do that as well. Let's go with to the right is positive.
Where's 0 again? Yeah, but physically on this?
So
E, I?
Yeah, there's my order right
Okay,
there.
all right.
So the,
All right, so that was E and I.
yeah.
Yeah.
Okay. Where is it positive?
From
Parentheses.
From E to the right, so E, I don't even know what that letter is. E to A?
What, this over here? That's a
E to
G.
G, yeah.
Okay. from E to
A's
G.
over here.
Okay,
All right, so from E to G.
yeah,
And
like, are you talking, okay, so bracket E, would it be bracket G or parentheses G?
Wouldn't be that.
'Cause you're including, but you're also,
it's parentheses.
What happened? Laura?
If it's past the origin, wouldn't all of those on that side of the origin be positive?
Yes, it would.
Like, all the way back to I?
Yeah.
E through
Okay,
I.
these are moments in time, so all the way from E to I
okay.
are
So it's
positive,
Okay.
not including, because E and I are 0.
So,
Oh, so what's
So it would be parenthesis E,
Parentheses, yeah.
I, close parenthesis.
Okay, that makes sense.
This will show up better. All right, and it should be negative, if we've done it correctly so far, it should be negative the rest of the time. How do we write that? Well, I know E is gonna be in parentheses, but we're starting here at time A to E.
A, parentheses E, and then you have to use a union for union.
Or E and I parentheses, and then I all the way to the end of the problem, which is M.
Oh, because we don't use a union.
Now, some students are into that math thing, and they'll put a union symbol in between them. I don't care. All right. Displacement. Where's displacement equal to 0?
I.
A.
Oh, nice A. Yeah, the box is over there.
Starting point. A.
Yeah.
When is it positive?
The
The whole time.
after A.
Other than.
Yeah.
A to G.
First this is A.
And
And then G to M.
Yeah. And
So-
M.
Yeah, A and
not
M.
including A, but all the way to M.
Including M.
Because again, we're dealing with where is it relative to the starting point. This is overall displacement. We're not concerned about which way it's going. We're just concerned with where is it.
Yeah.
And so this, not applicable. It's never to, on the negative side of the starting point. In this problem. Now what does this show up? Better. All right, velocity. When is the velocity 0?
Velocity is from.
I actually didn't specify this.
Is it
Any better thought out problem I would have.
So A is a 0.
So A at 0,
And then the peak of G would it be
all right, G is the turnaround point,
what?
and then that's what the problem, that's when it stops.
Oh,
It'd be more explicit, on the test. All right, so we have these 3 points right here. So if it's ever gonna change from plus to minus, it has to be at one of these points. At least one of them. All right, yes,
How
Tom?
did M become a rest point?
Yes,
How did it become a rest point though for M for velocity?
because I set it up that way.
Because like location wise, that's where it was at A. Is that?
It started here, it
Yeah.
speeds up, cruises along, speeds up again, cruises along, slows down, speeds up, cruises along, slows down, cruises, slows down, stops.
Oh, okay.
I threw friction in here, so that it wouldn't go back up to as high as it was to start with.
Oh, okay.
Okay.
If it were completely frictionless, it would end up back at A again,
Yeah.
and that's not as interesting.
So
Alright, so when is the velocity positive?
parentheses
Is
A.
it from A to G with those parentheses?
The velocity cares about which way you're going. I'm going to the right. From A, not including
Yeah.
to G.
I was getting there.
Wait, like G's on the
Oh,
zero.
that should be a parenthesis. Thank you. Yeah, if I put a bracket there, there's a mistake because I have G in two categories then. And if we've done it right, it should be negative everywhere else.
G to M. Parentheses.
And now,
Acceleration.
the biggest mistake I've seen up to here for the students who have problems is they get these backwards. I will tell you, on this last problem with the first test, on a problem like this, none of these will have the exact same answer all the way across the board. Which means, if you don't know which is which, and you decide, I'm just gonna put the same thing down for both so I get one of them right, what I've ended up doing is saying, you don't know what you're talking about, I'm giving you nothing. So, or, I'd have to look back to see what I've done, but you get less credit if you have any two of these identical across the board.
And that'll be like that the whole, every test? Like,
For-
for
this
all
type
of
problem where you're listing out where it's positive, negative, zero,
Yeah, none of the answers will be identical.
for across the entire problem, from A to M.
Yeah, but like for every test, though.
For every test,
Because you said you purposely weren't going to make the answers be the same for the first test,
oh, well, this is the first test is the only time we have a problem like this.
right? Okay.
And I'm not saying you get 0 credit for the entire problem, you just get 0 credit for the one that you just said, I don't know what this is, I'm just.
Yeah.
All right, acceleration. Now, this one's a little bit trickier. It might be easier to start out with when is it speeding up, when is it slowing down, and at least that'll hit, it'll hit half of it. If you know at this point where an acceleration would be 0, you can start there as well.
B to D.
No,
So-
Yeah, cause it's starting at rest, right?
Yep.
Yeah.
So it better be speeding up.
What the, yeah.
All right, so I had B on the flat here, I believe.
Yes.
Yeah, okay. So it speeds up, and I have written on this with a marker, but I might not to. So it speeds up here.
Yep.
Speeds up to D.
B to D.
Why would it speed up?
no, it's flat.
Wait, did I might have misheard the letters. You said D to E or?
Yeah.
D to E.
Oh, okay, yes. What about B to D?
It's 0.
It's constant.
Constant, yeah.
Velocity is constant?
Cruise.
Yeah. I'll just put a C for cruise.
And then E to F is
Oh.
constant,
E to F would also be constant, cruising.
and then F to G would be slow down.
I hope so, it's gonna turn around at D, G. G to H, H to I,
Constant.
I to J,
No,
J to L,
constant.
L to M.
Down.
All right. So I know that if the velocity is not changing, the acceleration is 0. Well, when it's cruising, we're only dealing with speeding up and slowing down really here. So, and when it's cruising, the acceleration is 0. So it's 0 in this region, it's 0 in this region. So my acceleration is 0 from B to D. And E to F.
H to I. And
J to
J
L.
to L.
When it's speeding up, it's gonna be the same sign as velocity. So from A to B, or A just before B, B is 0. Is it speeding up? It is speeding up as we decided. Is that positive acceleration or negative acceleration in the first region?
A to B.
Positive.
Positive, because velocity is positive,
Yeah.
acceleration will be positive as it's speeding up. So that is A to B. Another situation where there's acceleration when the velocity is 0.
And then
So we have A to B, B to D, so we have this D to E.
that's accelerations.
But it's
Positive.
both in parentheses.
Positive.
Pardon?
But it's both in parentheses.
Yes.
Yes.
So D to E. Then we have F to H.
What?
Or D to E,
Isn't that?
F to G.
F to G.
G to H.
G to H.
There we go. G to H is positive.
Why is it positive G to H?
It's going back.
But it's not on. It's gotta be the same sign. Because.
Therefore, oh, I thought you were saying it.
It's negative for G to H.
Right.
All right, from G to H, it's speeding up.
But it's going from negative directions, so it's negative acceleration.
The velocity is negative, so acceleration is
Negative.
Negative.
yes.
Yeah.
So that's G to H. H can't be included. What about G? Are we including G?
Yeah.
Uh-oh.
I got a yes and a, you said uh-oh?
Yeah.
Since
Yeah.
it was spoken with such great confidence, let's throw it in there. So we have done this region, this, and that,
Why is G in the bracket?
and that. Because she said so?
That is what happens.
Why, what would you do with G?
Would I just be in a parenthesis?
It's in his.
All right, let's
Oh,
deal
okay.
with that whole section
Okay,
there.
Okay.
From G to H, I hope we're in agreement that the acceleration is negative.
Yes.
From F to G, what is it?
Okay, I got it.
It's like the ball with the G when it reached the peak and then just started going down.
Yes, it is.
Yeah.
Yeah.
So from F to G,
Acceleration is also negative, but it would be considered slowing down because it's under the velocity.
it is slowing down,
Yeah.
and it's moving in the positive direction.
Yes.
Therefore, acceleration is the opposite sign, so the acceleration is negative. So this is why if you go back and forth, you have to include G at some point, but really it's negative the entire time. The first part of it slows it down, the second part of it speeds it up. And at the turnaround point, because it does keep moving, acceleration is not zero.
Okay.
H to I we dealt with, what about from I to J?
That's negative.
Negative.
Hold on.
Wait,
It's
wait.
Yes, hold on.
Why negative?
That's positive because it's slowing down.
Slowing down does not mean positive or negative.
Yeah.
Why would it be positive acceleration?
Why is it positive?
Because it's from G to M, it's a negative velocity, and if it's slowing down from the opposite, it would be a positive acceleration.
All right, so I to J, positive, so that's over here. I, comma, J. And then the last part we have is L to M.
Also positive.
But it includes.
That's
and-
positive, yeah.
It does include M, yes, so L, comma, M. I think, so A to B, B to D, D to E, E to F, F to H, H I,